Bitcoin and blockchain are a distributed computing solution. In the world of distributed computing, there are many nodes out on an open network transferring traffic. And so two of the important technical problems are, first of all, the double spend problem. Namely, with money, we don't want multiple copies of it made. We want to make sure it's only spent once. And so that's how the mining operation controls how wallets operate and only spend money once. The other big technical issue is called Byzantine fault tolerance. And so this gets its name from in Byzantium, when there would be very large battles and you would have a number of your Byzantine generals out on the war field, but you don't know if they're defecting, if they're colluding behind your back, if they're staying a healthy bona fide node fighting for your side, or if they've joined the other side or defected or become wounded. And so the issue is we don't know the status of nodes distributed out on our network. So how can we protect our network when we have these nodes and we don't know what's really happening with them? So that's what Byzantine fault tolerance is. Namely, can we identify and enforce good network players on our network? And so there are a number of solutions to this. So the first, namely proof of work and proof of sale, and then maybe prediction markets and maybe self-mining networks. So the big ones are proof of work and proof of stake. So proof of work is the consensus algorithm. So the consensus means how do we come to a new truth state of affairs in our network and update all nodes. And so blockchain is a state change machine. It maintains a state, i.e. this state of the ledger balances, until something happens, and then that truth state needs to be updated to the new truth state. I bought a cup of coffee, so my wallet balance is lower and the vendor's is higher. That's a new truth state of the network, and that information needs to be propagated and updated by all nodes. So the mechanism for updating the truth state of the network is called consensus. So consensus algorithms are what updates the truth state. And so consensus algorithms, the first one is called proof of work. And this is the mechanism for consensus used by the Bitcoin network. And so the proof of work is exactly this mining process of making the investment to guess at that random number, the nonce, 4 billion times per second, and investing that energy, a proof of work, performing the chip performs computational tasks in order to guess at that random number. And so it's conducting a proof of work to obtain the rewards, to convince the network software that it's a bona fide player, it is earnest, it means well, it is honestly trying to guess the number and reap the rewards for that work. It's providing a proof of work. And so that's the consensus algorithm by which the Bitcoin blockchain runs. The other big kind of consensus algorithm is called proof of stake. So instead of providing proof of work, a computation to guess the rewards for this transaction, a proof of stake is more like a voting system. So a proof of stake in the system. And so these systems typically have different entities called validators. Any network participant might be a validator, a transaction validator, and might post some of their stake in that network coin as a bond in escrow on the network as a convincing mechanism that it is ready to make good faith decisions about the quality of validating the transactions posted to the network. So either you would have proof of work, which is computational chips conducting cryptographic proofs, investing effort to try to guess a random number, or you would have proof of stake, which is more of a human-based and agent-based voting system where players on the network make a bond, put a proof of stake, a proof of their ownership of participating in this peer-to-peer network as a network peer-to-peer mechanism of confirming, validating, and booking transactions. Now, the thing with proof of stake algorithms is that they're fairly convoluted. Right now, there are several different ones under proposal, for example, from Ethereum, who is having a blend of a proof of work and a proof of stake consensus algorithm for booking transactions to the Ethereum network. There is also another method called Polkadot, another one proposed by Tendermint and Cosmos, and another one proposed by Dfinity. So these projects all have different modes, and Stellar is also a version of this. These kinds of proof of stake methods all have some sort of structure of network voters or validators that put a proof of coin down as a deposit for, say, at least 30 days in order to participate in validating network transactions. And there are typically multiple rounds of voting as to the quality of the proposed transactions. And so the network truth state can update only if there's a quorum or a 2/3 majority of validators supporting the new state of the network truth. My own view is that these methods are very convoluted right now, and they also depend on human intervention to a degree that may seem untrustable to new network participants. And so I think that over time, the proof of stake method might have to become more streamlined in order to be more adopted. So that's proof of work, proof of stake. There's also prediction markets, which is basically outsourcing the truth state of the network to other guessers from the outside. And so other parties can review and guess at the accuracy of the transactions to be booked to the network. So prediction markets is another open, straightforward mechanism by which truth states of the network could be arrived at. And rewards can also accrue to those that are performing the accounting operation of validating and booking new transactions to the ledger. And then a fourth method, I think, is self-mined networks. So this is a new kind of idea where algorithmic participants, not human participants in the network, could mine for each other. So any area, any sub area of a network needs to have its transactions booked and confirmed, and we could maintain independence by having one area mined for another area. And so maybe Canada mines the transactions for Iceland or something, and vice versa. So you could have a peer-to-peer based system of contributing work that is independent from your own effort, but yet is an efficient way to participate in the network. Because the problem is that proof of work is expensive, but it's a very nice cryptographic algorithm that works very well, but it's perhaps not scalable to other applications outside of finance, such as energy, Internet of Things, and healthcare, where because we're not transferring money as much, we don't need such a heavy cryptographic architecture to support the validity of the transactions. So we need something a little bit cheaper and more scalable than proof of work. Proof of scale seems to be too complex right now. Prediction markets are not going to be liquid enough for all of the different kinds of industry chains that we're going to need. So I believe we need some kind of algorithmic, self-mining, intelligent smart networks that do perform independent mining operations for each other. Another example of this could be in the smart home controlled over an IoT network where, say, the kitchen sensors mine for the bathroom sensors. So in other words, kitchen sensors are completely different from the bathroom sensors, but they merely look, validate, and confirm and book the transactions from another part of the diverse operation. And so I think self-mining networks in the future will be another mode by which we might enforce consensus, come to consensus and truth states on our smart networks.